Welcome to 3-hinged parabolic arch with supports at different levels. You can see the figure. In this figure, you can just see support A and support B are at different levels. This is a combination of two arches. For example, you can see one is a smaller arch. You can see here this is a smaller arch and this is the larger arch. So if I combined the left half of the smaller arch and the right half of the larger arch, that is nothing but the left portion of this arch and the right portion of this arch, if I combine it together, you'll get this particular arch. Okay, hence this arch is the combination of smaller arch and a larger arch. And here in the usual problem, the height h1 and height h2 will be given, and the total span of the arch will be given, and that is nothing but L. Okay, so the thing is, you need to calculate what is the span of smaller arch, that is half of L1, that is L1, and the span of this larger arch L2, that you need to find. So that can be found using this particular formula. You can see here, this is the this is for calculation of length L1, and this is for the calculation of length L2. It is nothing but and using this formula you can calculate the small length L1 and small length L2. So the next part of what you need to understand here is the points D and point E. If in the problem, if they ask you to calculate the normal thrust and radial shear at this particular point D and at point E, what you have to do is, you need to consider, for example, if you consider point D, okay, you are going to calculate normal thrust and radial shear at point D, then you need to consider that particular point in this particular arch. Now this is your point D here. So first thing you have to do is calculate the span of that smaller arch, which is nothing but L, which is equal to 2 times L1. Okay, and you can substitute in this particular formula, that is y is equal to 4h by L square into Lx minus x square if it is required, or you can calculate theta using this formula. It is 4h by L square, where L here you should consider this particular value of L is nothing but this value of L. L is equal to 2 times L1. This is for normal thrust and radial shear at point D. Okay, if you are going to calculate that in point E, then you have to go with then you have to do this thing. You need to, if you are going with point E, calculation of normal thrust and radial shear at point E, then you need to consider this particular arch, where the span of the arch is nothing but L, which is equal to 2 times of L2. This value of L2 you will obtain from this particular equation. So once you get L2 and the total span is equal to 2 times of L2, then you need to substitute in this particular equations, so that corresponding value of y, if it is required to calculate, you can calculate, and the corresponding value of theta also you can calculate using this formula. Okay, next we will see one problem. And this is the problem. It reads, calculate the reaction, normal thrust and radial shear at 5 meter from left and right support for the 3-hinged parabolic arch shown in figure. Okay, you can see a 3-hinged parabolic arch with supports at different levels, and the loading is given. One is 10 kilonewton, which is 3 meter from left support, and 25 kilonewton, which is 4 meter from right support. So AC is a smaller arch, whereas BC is a larger arch. Here you can see the height of the smaller arch is 3, whereas the height of larger arch is from this point to this point, that is 6 meter. Okay, now so first thing you have to do is need to go with the calculation of L1, that is half of span of smaller arch and half of span of larger arch, L1 and L2. For that, the given data are total span of the arch is given, that is 36 meter, hence L is equal to 36 meter, and height of arch is given, height of smaller arch is H1 and the height of larger arch is 6 meter. So H1 and H2 are given. So we will substitute in the formula to calculate L1 and L2. So the substitution you can see, and L1 we got the answer as 14.91 and L2 you got the answer as 21.09 meter. So substitute, you will get the answer. Now you can see the calculation of reaction. So when you go with the calculation of reaction, first we will go with the summation of vertical force is equal to 0. That is, we will apply this particular equation. So when you apply this equation, when you add all the vertical forces here are VA, second one is 10 kilonewton, that is this one, third one is 25 kilonewton, and VB is acting upward. So VA and VB are acting upward, 10 kilonewton and 25 kilonewton acting downside. So we'll get the equation as VA plus VB minus 10 minus 25, which is equal to 0. So VA plus VB is equal to 35. Similarly, we'll apply summation of horizontal force should be equal to 0. We'll apply the second equilibrium equation. So you have only two forces, one is HA, second one is HB. HA is moving right side, HB is moving left side, hence HA is equal to HB. Next we'll apply the third equilibrium equation, that is summation of moment at A is equal to 0. When I apply summation of moment at A is equal to 0, you can see here 10 kilonewton is the perpendicular distance from A is 3 meter, and 25 kilonewton the perpendicular distance from A is, total span is 36 minus this particular 4 meter, it is 32 meters. So 25 into 32. Again the next thing is VB, it is anti-clockwise with respect to A. VB is acting anti-clockwise, hence VB into perpendicular distance is 36. Along with that we will get HB also, it is acting clockwise, so plus HB into perpendicular distance from VB is 3 meter, hence this value you need to consider. Okay, so the same thing I have written here, it is 10 into 3 plus 25 into 32 minus VB into 36 plus HB into 3, so that we will get one equation, that is equation number 3. Okay, this is equation number 3. Similarly, we have bending moment at C is equal to 0. When we apply bending moment at C is equal to 0, we will get the equation something like this, minus 25 into 17.09, that is the distance from C to 25 is, we have calculated L2, the value of L2 is 21.09. From 21.09, if I deduct 4 meter, I will get 17.09. So 25 minus 25 into 17.09, this value is 17.09. Okay, 17.09, and we have VB, that is VB plus VB into perpendicular distance is L2, the answer we already have, and minus HB into perpendicular distance is 6. So the same thing I have written, minus 25 into 17.09 minus HB into 6 plus VB into 21. So we will get one more equation, that is equation number 4. Solving equation 3 and equation 4, we will get the answer for VB as well as HB. Hence we got the answer for VB and HB. Now substituting in particular equation 1 and equation 2, we will get the answer for VA and we will get the answer for VA, HA, VB and HB. So HA and HB will be same, and we got the answer for VA and VB. Now, so calculation of normal thrust and radial shear at 5 meter from left support. So whenever we consider 5 meter from left support, that comes under a smaller arch. So we have the reaction VA is 10.79 and HA I have written it is 13.90. Here the equation for normal thrust and radial shear are N is equal to V sin theta and H cos theta. Similarly, radial shear we have Q is equal to V cos theta minus H sin theta. Here you need to find what is V, what is H, what is theta. For that, first we need to equation, we will write the equation something like this: V is downside and H is towards left hand side, and we will apply the summation of vertical force is equal to 0 for this particular figure. When you apply for this particular figure, you can we will get something like this: 10.79, that is VA is moving upward, and minus 10 which is acting downside, minus V is also acting downside. This should be equal to 0, hence we will get V is equal to 0.79. Similarly, if I apply summation of horizontal force equal to 0, directly I will get the answer for H as 13.90 kilonewton. Next, in order to find theta, the formula is this one. Here, as I mentioned in the previous part, that the span L you need to consider is 2 times of L1, because you are calculating normal thrust and radial shear in the smaller arch. Hence, the span becomes 29.82. This is the important point you need to know. Hence, we will substitute in the formula theta is equal to tan inverse of 4H by L square. Here L you can see it is 29.82, and when you substitute in that way, you will get the answer for theta, from which directly you can substitute in the equation and calculate what is normal thrust and radial shear for that particular value. Okay. Next is the calculation of normal thrust and radial shear in on 5 meter from right support. So equation of normal thrust and radial shear are same. Here calculation of V and H, you have to do it once again. So we will write the 5 meters, the figure of 5 meter from right support. This is the figure of 5 meter from right support. Okay, here VB is 24.21, HB is same 13.90, and for this particular figure we will apply summation of V is equal to 0. When we apply summation of V is equal to 0, we have 3 vertical forces. VB is moving upward, 25 is acting downside, and V is also acting downside. The answer for VB is 24.21, and when you substitute, you will get the answer for V as minus 0.79. Similarly, we will apply summation of H is equal to 0 for this particular figure. We have only 2 horizontal forces, one is H, the second one is 13.90. When you substitute, you will get the answer for H as 13.90. And again, for using the equation, in order to calculate theta, you can use this particular equation where H is nothing but 6 meter and L is nothing but 2 times of L2, that is 42.818 meter. So once you substitute that, you will get the answer for theta. Now you can substitute in the normal thrust and radial shear equations, and you will get the appropriate answers. This is the one problem I have solved using I have solved for 3 hinged parabolic arch with supports at different levels. Thank you.